Hello, welcome to my YouTube channel, that is Mechanical Engineering. In this video we are going to discuss the very important topic, that is single point cutting tool, which is most commonly used in the process of turning, then the boring and shaping. So the single point cutting tool is most widely used in all over the workshop. That is why I have chosen this topic. So this is nothing but the CAD model of a single point cutting tool, which is showing its different part. Now this portion is known as shank of the cutting tool. So shank is nothing but the major body of the cutting tool. Then this portion is known as face of the cutting tool. So the surface over which the chip flows during the machining process is known as face of the cutting tool. Now the single point cutting tool has two cutting edges, that is side cutting edge and the end cutting edge. And the point at which these two cutting edges intersect, that is known as nose of the cutting tool. So this is nothing but nose of the cutting tool, where the side cutting edge and end cutting edge, they are intersecting together. Now this portion, the portion immediately below the side cutting edge, that is known as major flank, and the portion immediately below the end cutting edge, that is known as minor flank. So this is a minor flank and this is the major flank, and this is nothing but the heel of the single point cutting tool. And here you can see the base of the cutting tool, on which the single point cutting tool rests. Okay, so shank is nothing but the main body of the cutting tool, and with this shank you can hold the single point cutting tool in a tool post or in the tool turret in your lathe machine. So these are nothing but the major parts of a single point cutting tool. Now we will discuss the tool signature of a single point cutting tool. That means the various angles associated with a single point cutting tool. So for better understanding the various angles, we have taken its orthographic projection. So here you can see this is nothing but a front view, this is top view, and this one is a side view. Okay, so this is, again I am repeating, this is the front view of a single point cutting tool, this is top view of a single point cutting tool, and this is a side view of a single point cutting tool. So if you look this tool from this side, if you look this cutting tool, then this will be the front view, this will be the front view, this will be the top view, and this will be the side view. Sorry, this will be the side view. Okay, this portion will be the side view. So same things you are getting here. Okay, so now we will discuss the various angles associated with single point cutting tool. So the very important angle, that is nothing but back rake angle, that you can see in the front view. So this is nothing but the back rake angle. Okay, so the angle made by the face of the cutting tool. Now this portion is known as face of the cutting tool, which is inclined at a back side. Okay, it is inclined downward. So the angle made by the face of the cutting tool and a line parallel to the base of the cutting tool. Okay, so the angle made by the face of the cutting tool and a line parallel to the base of the cutting tool measured in a plane which is perpendicular to the base of the cutting tool and passing through the side cutting edge, that is known as back rake angle. So here you have to carefully understand the back rake angle. So back rake angle is nothing but the angle made by the face of the cutting tool with the line parallel to the base of the cutting tool, and it is measured in a plane which is perpendicular to the base and passing through the side cutting edge, that is known as back rake angle. Now if this face is inclined downward, then that angle is known as positive rake angle. Now this face is inclined downward, so here the tool has given positive rake angle. If this face is inclined in such fashion, okay, then that is known as negative rake angle. And if this face is exactly parallel to your base of the cutting tool, then it is a zero rake angle. Okay, so back rake angle can be a positive rake angle if the face of the cutting tool is inclined downward. It may be a negative rake angle if the face of the cutting tool is inclined upward, and if it is parallel to the base of the cutting tool, then it is known as zero rake angle. Okay, so this is all about your back rake angle. Now the next angle, that is a side rake angle. Here you can see the side rake angle, which is clearly defined with the help of your side view. Now how this side view we can get? So just imagine, just observe this diagram. If you look this cutting tool from this side, so this will be the front view and this will be the side view. So from this side, this cutting tool will look like this. So if you observe this cutting tool from the left hand, then it will look like this. Okay, and again, now this face is inclined at this side also. Here you can see this line and this line, they are not parallel to each other. This line is inclined downward. This line is inclined downward. That means the entire face is downward. The entire face is inclined downward. Okay, so that means this line is making some angle with a plane which is parallel to the base of the cutting tool. Okay, so here you can see the side rake angle. Now this is nothing but this is a face of the cutting tool. Now this face of the cutting tool is making some angle with a line which is parallel to the base of the cutting tool, and that angle is known as a side rake angle. Okay, so this is a side rake angle. Now we will discuss the next angle, that is end relief angle. Okay, so here you can see the end relief angle. So the angle in between this line and this line, that is known as end relief angle. Here you can see end relief angle. So the angle made by the surface immediately below the nose of the cutting tool. Now this point is known as nose of the cutting tool. So the angle made by the surface immediately below the nose of the cutting tool and a line perpendicular to the base of the cutting tool and measured in a plane which is perpendicular to the flank of the cutting tool, that is known as end relief angle. So if you understand this diagram carefully, then you can easily write the definition of each and every angle. Okay, so here you can see the end relief angle. It is nothing but the angle made by the surface immediately below the point of the cutting tool and a line perpendicular to the base of the cutting tool and measured in a plane which is perpendicular to the flank, that is known as end relief angle. Now we will discuss the next angle, that is side relief angle. So here you can see a side relief angle. Okay, so this is nothing but side relief angle. So for getting side relief angle, again you can see the side view of the cutting tool. So again we will look the CAD model, the 3D CAD model, the isotropic view of the cutting tool. Now this is the isotropic, and in the next slide, that is orthographic view. Now here you can see these are two different surfaces or the sides of the cutting tool. This is the side of a cutting tool and this is also a side of the cutting tool. Now these two sides are not parallel to each other exactly. Okay, this side and this side, they are not parallel to each other. Here you can see some gap. That means this side is inclined, somewhat inclined to this side. Now this angle is nothing but the side relief angle that you can see over here. Okay, now the side relief angle is nothing but the angle made by the side of the cutting tool or the angle made by the surface which is below the side cutting edge, the angle made by the surface which is below the side cutting edge. Okay, and the side of the cutting tool, that is known as side relief angle. So side relief angle is nothing but the angle made by the surface which is immediately below the side cutting edge and the side of the cutting tool is known as side relief angle. Now next angle, that is end cutting edge angle. So here you can see the end cutting edge angle. This is nothing but end cutting edge angle. So the angle made by the end cutting edge and the line perpendicular to the shank of the cutting tool, that is known as end cutting edge angle. So here you can see the angle made by the end cutting edge and the line perpendicular to the shank of the cutting tool is known as end cutting edge angle. Okay, and here you can see the side cutting edge angle. So it is nothing but the angle made by the side of the cutting edge. It is the angle in between the side cutting edge and the side of the shank is known as side cutting edge angle. So these are nothing but different angles associated with a single point cutting tool. So again I am repeating the first angle, that is back rake angle. So back rake angle is the angle between the face of the single point cutting tool and a line parallel with the base of the tool measured in a perpendicular plane through the side cutting edge. If the slope is downward towards the nose, it is negative back rake angle, and if the slope upwards towards the nose, it is positive rake angle. If the back rake angle helps in removing the chips away from the workpiece. Now the role of the back rake angle is to remove the chips away from the workpiece. That is the role of back rake angle. Now side rake angle. Side rake angle is the angle by which the face of the tool is inclined sideways. Side rake angle is the angle between the surface of the flank immediately below the point and the line down from the point perpendicular to the base. Side rake angle of a cutting tool determines the thickness of the tool behind the cutting edge. Okay, it is provided on the tool to provide clearance between the workpiece and the tool so as to prevent the rubbing of the workpiece with end flank of the tool. This is very important because your workpiece should not rub with the cutting tool, and that is why side rake angle is provided. End relief angle. So here I am showing the end relief angle. This is nothing but the end relief angle. Here you can see at the bottom. This is end relief angle. So end relief angle is defined as the angle between the portion of the end flank immediately below the cutting edge and a line perpendicular to the base of the tool measured at right angle to the flank. End relief angle allows the tool to cut without rubbing on the workpiece. So end relief angle is very important because the surface below the point that will come in contact with the workpiece, that may come in contact with the workpiece. So we have to provide some angle so that it should provide some relief to the workpiece. Next is a side relief angle. So side relief angle is the angle between the portion of the side flank immediately below the side edge and a line perpendicular to the base of the tool measured at right angle to the side. Side relief angle is the angle that prevents the interference as the tool enters the material. Okay. Then end cutting edge angle. So end cutting edge angle is the angle between end cutting edge and a line perpendicular to the shank of the tool. This we have already discussed. And then side cutting edge is the angle between the straight cutting edge on the side and side of the shank. This is side cutting edge angle. So these are nothing but different angles which are associated with the cutting tool. And one more parameter is there, that is nothing but nose of the cutting tool. Now this point is known as nose of the cutting tool, or here you can see this is nothing but the nose of the cutting tool. So it is not sharp, it has some radius. Okay, so that is the last parameter that is associated with single point cutting tool. Now we will discuss the tool signature. Okay, so the single point cutting tool is known by its signature. So the 7 elements that comprise the signature of a single point cutting tool are always stated in a following order. So your tool signature should be stated in this order only. Okay, so here I have written a typical tool signature. It may be different for a different tool. So here I have taken one example. The tool signature is 07681516.8. Now each location has its own meaning. So first location is for back rake angle, which is here 0 degree. Second location is side rake angle, which is 7 degree here. Third location is for end relief angle, which is 6 degree here. Fourth location is side relief angle, which is 8 degree here. Then fifth location is end cutting edge angle, which is 15 degree here. Then the next location is for side cutting edge angle, that is 16 degree. And the seventh location is for nose radius. Here I have taken 0.8 mm nose radius. So for different operation you can take a tool with different nose radius. Suppose if I am performing a roughing operation, at that time I have to cut more material. Okay, so there will be more stresses over your cutting tool. So that time you have to take the cutting tool with more nose radius like 0.8 mm. If I am performing finishing operation, that time I am removing very less material. So that time I can take a tool with 0.4 mm as a nose radius. So this is nothing but a tool signature for a single point cutting tool. Now we will discuss the various cutting tool material, means the material out of which your single point cutting tool is made of. Okay, so before that we will discuss some basic property that your single point cutting tool should have. So the very first property, that is tool material must be at least 30 to 50% harder than the workpiece material. So your cutting tool material should be 30 to 50% harder, then and then it can remove the material from the workpiece. So it should be 30 to 50% harder than the workpiece material. The next is tool material must have high hot hardness temperature. So see, when there is machining, that time we are removing the material from the surface of the workpiece. So there is a friction in between the tool and the workpiece. Due to friction, the heat is generated. Okay, so as the heat generate, as the temperature rises, the hardness reduces. Okay, so your cutting tool material should not lose its hardness at high temperature. So the tool material must have high hot hardness at a high temperature. Then high toughness. So as the cutting takes place, the tool is subjected to the shock. So it should ready to absorb the energies. It should ready to absorb the cutting forces. So it should have high toughness. Then it should have high wear resistance. Then it should have high thermal conductivity. That means it should conduct the heat easily. Okay, if it's towards the heat inside it, then the temperature will get increased and its hardness will get reduced. So it should conduct the heat. Then lower coefficient of friction, as there is a friction in between cutting tool and the workpiece, but the cutting tool should offer low friction. Then easiness in fabrication and cheap. So the cutting tool material should be cheap, because if it is costly, then the cost of production will get increased, and ultimately the cost of product will get increased. So the cutting tool material should be cheap. And easiness in fabrication, so you should be able to fabricate it easily. So these are some properties that the cutting tool material should possess. Now we will discuss the various alloying element. So the various elements are added, alloying elements are added to the cutting tool material so as to improve its quality. So the very first element, that is tungsten, it increases the hot hardness, then it forms the hard carbide and it increases the abrasion resistance. Then the molybdenum, it also increases the hot hardness, then hard carbide form, and it also improves the resistance. Then chromium is added, so depth hardenability during the heat treatment is increased. Then carbides are formed, again abrasion resistance get increased by the addition of chromium, and we are getting some corrosion resistance if the chromium is added, because while machining the cutting fluid is used. So the cutting tool is come in contact with the cutting fluid, so it may corrode. So to avoid that corrosion, sometimes chromium is also added. Then vanadium, it combines with the carbon for wear resistance, and it retains the grain growth for better toughness. Then cobalt and carbon, they are added to the material of a single point cutting tool. So these are nothing but some alloying elements which are added for improving its properties. Now we will be discussing the various cutting tool material. So the very first cutting tool material, that is high carbon steel tool. So its composition is carbon is 0.8 to 1.3%, silicon is 0.1 to 0.4%, and manganese is 0.1 to 0.4%, and remaining will be your iron. Okay, so that is the composition of high carbon tool steel. It is used for machining soft materials like free cutting steel and brass, and used as a chisel. Okay, so this high carbon tool steel is used for cutting soft steel. You cannot cut hard material with the help of the tool which is made up of high carbon steel tool. Then this tool lose hardness about 250 degrees Celsius. That means you cannot use this tool above 250 degrees Celsius. It can be used below 250 degrees Celsius because it will lose its hardness. Then its hardness is about 65 RC, and it is used at a cutting speed 5 meter per minute. So these are nothing but the properties of a high carbon steel tool. The next material, that is high speed steel. So HSS is 1841. Okay, so general use of HSS is 1841, that is 18 tungsten is used to increase the 18 percentage of tungsten, 4% of chromium and 1% of vanadium. So tungsten is used to increase the hot hardness, chromium is used to increase the strength, and vanadium is used to maintain the keenness of the cutting edge. Okay, then in addition to this, 2.5% to 10% cobalt is also used to increase its hardness, and rest is iron. Okay, so HSS is used for drill bits, milling cutters, single point cutting tools, dies and reamers. It loses its hardness above 600 degrees Celsius. Okay, the earlier tool, that is high carbon tool steel, it loses its hardness above 250 degrees Celsius, where high speed steel loses its hardness above 600 degrees Celsius. Then sometimes tungsten is completely replaced by molybdenum. Now next material, that is non-ferrous cast alloy. So it is an alloy of cobalt, chromium, tungsten and carbon. Cobalt is 40 to 50%, chromium 27 to 32%, tungsten is 14 to 29% and carbon is 2 to 4%. It loses its hardness above 800 degrees Celsius. So here you can see this cutting tool can be used up to 800 degrees Celsius. Beyond that, it will lose its hardness. Then it will give better tool life than high speed steel, and it can be used at slightly higher cutting speed. They are weak in tension, like all cast material, tend to shatter when subjected to the shock, load, or when not properly supported. Next material, that is cemented carbide. So it is produced by powder metallurgy techniques with the sintering at 1000 degrees Celsius. So as it is made up of cemented carbide, so the best method for manufacturing this cutting tool is with the help of powder metallurgy. It can be used at the speed 6 to 8 times more than that of high speed steel, and it can withstand up to 1000 degrees Celsius. So you can use these cutting tools up to 1000 degrees Celsius. It has high compressive strength, that the tensile strength, as it is made up through powder metallurgy techniques. They are very stiff, and their Young's modulus is about 3 times than that of the steel. Again, it has high modulus of elasticity, high wear resistance, low coefficient of thermal expansion, high thermal conductivity, low specific heat and low thermal expansion. And the last material, that is diamond. So even the cutting tool is made up of diamond also, which are very costly. So it has extreme hardness, low thermal expansion, high thermal conductivity and very low coefficient of friction. These are very important properties of the diamond. Then cutting tool made up of diamond can withstand with the speed ranging from 1500 to 2000 meter per minute. On ferrous metal, diamond are not suitable because of the fusion of carbon atoms from the diamond to workpiece. It can withstand above temperature 15 degrees Celsius. So you can see the temperature. Okay, so these are nothing but various cutting tool materials. So thank you so much for watching my video. In this video, we have discussed the various angles which are associated with the cutting tool, then the tool signatures and the various cutting tool material. Thank you so much.